Okay, this is the first program. The second line is the actual program, and the first line is just a comment that says that this program does nothing. The program has first a keyword, fn, that stands for function. Then the word main, it says that this function is named main. Every REST program must contain a function named main. You can write a software that is a library that does not contain a main function, but every complete Rust program must contain a main function. Then we have a pair of parentheses that contains the arguments of the function. We have no arguments. And then there are a pair of braces that contains the statements of the function. We have no statements. Let's pass to the second program. This has one statement. It is a print followed by hello world. Of course, this program just prints hello world. Let's analyze this statement. First, there is the word print. Print is the name of a macro, of a standard library macro. It is not a function, although it is similar to a function. You can say it's a macro and not a function because it's followed by an exclamation mark. Every Rust macro and has a name that ends with an exclamation mark. Then we have parentheses containing a string. The string is delimited by double quotes and has as contents hello world. After the string literal and the closed parentheses, we have a semicolon that ends this statement. This statement just prints, of course, its only argument. Let's pass to the third program. This program is not valid. It's illegal. Why? Because it defines a function named main, but with a capital M. Rust is case sensitive, so this function is different from the main function we saw before, and you cannot have a program without a main function with the lowercase m. This can be a library, but not a program. If you try to compile this as a program, you get a compilation error. You get the error that this program does not contain a main function. Then we have another program that prints hello world on the console. It contains in parentheses 3 arguments separated by commas. The first argument is a string literal. The second argument is another string literal containing hello, and the third argument is another string literal containing hello, containing world. The first string literal, that is the first argument to the print macro, is a bit weird. We have a pair of braces, a comma, a blank, another pair of braces, and an exclamation mark. This is the pattern that is printed, and the braces are placeholders that are replaced by the following string literals. The first pair of braces is replaced by the string hello. The second pair of braces is replaced by the string world. So we have, after this substitution, hello, comma, blank, world, question mark. The result is hello world, like the first the program that saw before. This replacement is similar to the replacement of printf in C language, you could say, but that's not exactly the same. The corresponding in C language is this. you have this placeholder that matches this string literal, and this placeholder then matches this other string literal. But there are differences. First of all, you have to specify that the type of the string literal is a string, S. In Rust, we didn't do that because Rust is capable of recognizing that string literals are string literals, and so they can infer the type. You have to specify in C. You have to specify the type, and if you specify the wrong type, you get undefined behavior. But this is not the only difference. Consider this Rust program that is illegal. We have just one placeholder, but two arguments after the template. Rust counts the placeholders and the arguments after the first one. The compiler sees that we have just one placeholder and two arguments. They don't match, so a compilation error ensues. This other program is also illegal. You have two placeholders and just one argument to use for those. So they don't match. You have another compilation error. In Rust, you can use just one print macro to print several lines. There are several possibilities to do that. First of all, we have just one string literal that contains first line \n that represents an underline marker, second line another \n, third line another \n. The result is first line, second line, third line in three different lines. This \n is an escape sequence that is replaced by the end of line character of your operating system. If you're using Unix or Linux, you have the end of line character. If you're using Windows, you have carriage return and line feed character sequence. But there are other possibilities to do several lines. One is to use another standard library macro, printLn, written println. You write just the text of the line and you get an underline at the end of it. This is quite handy, as very often you have to write a line that ends with an underline marker. So you can use this macro instead of adding \n at the end of the line. This is the other possibility. You have write just print and add \n at the end of the line. Now consider this. We print my number 140. It's just one string literal, and the result, of course, is this. It's just the same as we specified. We can obtain the same result in other ways. For example, my number placeholder, it is replaced by the string 140. 140 is a string of 3 characters. But another possibility, you write 140 without quotation marks. This is not a string literal, it is a number literal, and precisely an integer number literal. Rust can infer the type of such an expression. It is no more a type string, it is of type number. The the placeholder is replaced by the string 140 because Rust translates this number to a string of 3 characters, 140, and replaces those characters, these braces with those characters. Also, this program prints my number 140. We added 3 zeros in front of 140. What happened? This string of 6 characters in our source code gets translated to a binary code that contains a binary number representing the number 140, just the same of the number 140 that I saw before. This number at runtime gets translated to the string 140, and that string is substituted for the placeholder of the braces. Here is another way to print the same string. We have the pattern string containing 2 matches. Two placeholders. The first one matches with the literal string my number. The second one matches with the integer number literal 140. So we print my number 140 with the 2 replacements. The first one of a literal string, the second one of a literal number. This is a trick to obtain a good result when you compile. If you write a long program and this program contains several errors, you get on the console a list of all the errors the compiler encounters. You get a very long list, and at the end you see the last error. But it's not a good idea to start analyzing the last error. It's better to consider first the first error, because often the last error depends on a previous error. So you have to roll back to the first error after the command. That's not easy to do, so you can use this the small script written for Unix or Linux, where you run your Rust C compiler with all the arguments you provide, and with this other argument, color always, to keep the colors emitted by the compiler. Colors are useful to spot source code, error message, and other parts of the output. This expression says that error standard stream should flow into the standard output stream, and all the standard output stream is piped into the more command that stops after the first transfer. So you see the first error on the screen, then you can strike a Q to stop the compiler from emitting other error messages that are not interested, because you have to correct the first error first, and then you can rerun this script. But this is not about Rust language, it's just about the environment used to compile the language. This is the version for Windows, the same program. Then we can analyze this program that contains several comments. Well, you can easily embed comments into your programs. There are two kinds of comments. One is the C-style /*//. It is a multi-line program like this one. Or you can use the C++ style used today also by other languages, double slash, that is a single line comment. The standard in programming Rust is to use single line comments, even if you have several lines, like in this case. You just repeat the comment sequence at every line. This kind of comment is not recommended. Well, it is used just to omit a part of code, to comment out about a code that you temporarily you don't want to compile. Then consider this. We have open comment, another open comment, close comment. Which comment are we going to close? This or this? Well, in C and almost all other languages, comments do not nest. So this sign is ignored, and this sign closes this. This is a complete comment in C language and in C++. This is another comment that starts here and ends here. So the string comment, even is compiled by the compiler, and this is not correct in C. But in Rust, comments do nest. So in Rust, this is a sub-comment. This, well, this is another sub-comment. This is another sub-comment. And this is a whole comment. This is correct in Rust, but this program is illegal, as we wrote here. Why? Because the error lays in the last lines. We open the comment, open another comment. Here we close the inner comment, but the outer comment is never closed. So there is a comment open but never closed. This close brace is still inside the comment beginning here. So we have a compilation error. Well, if it were C language, it would be tolerated, but in Rust, no. Now consider this. The second argument of the print macro is an expression, 80 plus 34. It's an arithmetic expression that is evaluated. It computes, of course, a sum, and the result is transformed into a string, the string 114, and is replaced. It is used to replace this placeholder. So the result of the behavior of the program is to print the sum is 114. Let's see this program. We have several arguments after the first one. The literal number 34, the literal number 80, and the expression between two literal numbers 80 and 34 summed. Well, 34 is used to replace this placeholder. 80 is used to replace this placeholder. 80 plus 34 is evaluated, and the result is used to replace this placeholder. So we get 34 plus 80 equals 114. This is a bit more complex. We have just one placeholder, and so just one argument, but it is a rather complex expression. 23 minus 6, remainder 5, plus 20 times 30 divided by 3 plus 4. This is quite similar to C language. So if you know C language, it wouldn't be surprising for you. As in C language, you have to respect parentheses for precedence, and also operators have an inner precedence. Multiplication has a precedence over addition. This is also a kind of division. It is the remainder operator. Well, not to be confused with the modulus operator. Well, modulus and remainder are the same if the arguments are positive, but they differ if the arguments are negative. So how is it evaluated this? First of all, we evaluate 23 minus 6. Then we evaluate 3 plus 4, because they are in parentheses. Then we evaluate this expression. Then we evaluate this expression. Then we evaluate the division. So this expression, and at the end we evaluate this addition. So we get as final result 87. Notice that all these are integer numbers. Of course, if you add or subtract integer numbers, you'll get an integer number, and also if you multiply them. But if you divide an integer number by another integer number, in Rust you get always an integer number. So the result is truncated. You never get a floating point number or a rational number. You get always an integer number. So we get 87, even if this number is not exactly divisible by this number. The result is truncated. In Rust we also have floating point numbers or fractional numbers. We can evaluate 80.3 plus 34.8. The result is 115.1. For fractional numbers, the standard floating point numbers are used, like in C and C++. So it wouldn't be a surprise to obtain at 80.3 plus 34.9 is not a number with just one decimal digit. It has a lot of a decimal digit. Is 115.1 followed by a streak of nines. How many? Well, it depends on the precision of the floating point numeric format. Many nines. I don't explain why it is so, but it's the same as in other languages using floating point standard format. This is the same expression we saw before with integer number translated using floating point numbers. We don't have 23 anymore, we have 23 dot. This dot makes this a floating point literal number. 6 is also a floating point number, and 5 and 20 and 30 and 3 and 4. The result is not the same as before, because this division is a division between floating point numbers, so you don't have to truncate to an integer number. The result so is not 87 anymore, is 87 dot a lot of other digits. In C, C++, and many other languages, this expression is allowed. In Rust, it is not. Why? Because 2.7 is a floating point number. 1 is an integer number. They have two different types. You cannot combine two different types in the same expression. You cannot add a floating point number to an integer number. Of course, if you have to, you must convert one of them in another type. But without conversions, you cannot do that. Well, also in C language, the conversion is automatic. If you write this in C language 1, it is written as an integer number, but it is automatically converted to floating point number. And plus is an addition between floating point numbers. Well, in Rust, this implicit conversion does not happen. You have to do it yourself if you want. So it avoids some kind of subtle bugs. Here it is one way to obtain the desired result is add a dot. This is no more an integer number, now it is a floating point number, so you can add these two floating point numbers, and the result is 3.7. This is the use of the remainder operator. It means this expression means that I take the number minus 12, I divide, that is an integer number, I divide it by the 10 integer number, and the remainder of the division after the truncation is what I get. It is minus 2. In Rust, the remainder operator is defined also for floating point numbers. In C language, you have to use the fmod library function. In Rust, you can use this operator that is applied directly to the floating point numbers. So it is actually equivalent to the fmod standard library function of the C language. And after this operator, you get minus 0.1 and a streak of 9 and then ended 6. We can write several statements in a function. Up to now we wrote just one statement, but of course it's quite unusual to write just one statement. We wrote 3 statements. They are all invocations of the print macro, but of course that's not necessarily required. And these statements are separated by semicolon. We have 3 semicolons at the end of each statement, like in C language. White space is not significant in Rust. We can indent correctly the first statement, but we can indent differently the second and the third statement. We can attach the second statement just after the first one with no intervening space or blank. So this is correct, although quite hard to read. But additional spaces are not significant. And if you want to write a string literal on several lines, because it is very long and we cannot or we don't want to keep in on just one line, how could we do? Well, in C language you had to write this kind of expression. Well, in Rust it is not allowed. You cannot just split string literals into string literals. You have to do something different. You have to open the string literal with double quotes and just pass to another line with no termination. These are 3 lines. This is just one literal containing 3 lines, because the underline marker in source code is part of the string literal. But also these blanks are part of the string literal, and also these. So the result is this. These are 3 lines that contains the new line characters and the blanks. Perhaps you don't want blanks, so this is not satisfying. Perhaps you don't want the new line also. You can use this escape character, the backslash, to say that the following underline character is not to be considered as a part of the string literal. This string literal starts here, contains these 4 letters, a blank. This new line is ignored, and also the following blanks are ignored. Then you have is blank, all this is ignored, and then you have just one line. The result is this is just one line. Of course, before the backslash, you have to write one blank here and also here, because otherwise there were no blanks, and you obtain, if you wrote so, well, you got this result, because there would be no blanks anymore. Okay. And if you want the new lines but not the spaces, well, you can write this. These new line, no blanks are, and you get this. These are 3 lines. Perhaps you want this output, but you don't want this ugly source code. You want to indent it. How could you do that? I lost my... Well, you can write this. You can write these. You explicit the new line character as an escape sequence. Then you write another escape character that says to avoid the new line character and the following blanks. So you get this new line, R, new line, ignore this, 3 lines. The result is these are 3 lines. Okay.